Hello, Algebra 2 students. Today we will be doing 12.4 notes, finding sums of infinite geometric series. Now, previously you have been able to find the sum of a finite geometric series by using a specific formula. The same applies for an infinite geometric series. There is no such thing as the sum of an infinite arithmetic series because you're never going to reach a certain number. So the sum of an infinite geometric series with first term a sub 1 and the common ratio r is given by the following formula. And the following formula says that the sum is equal to the first term divided by 1 minus the common ratio. However, you can only use that formula if this holds true. So the absolute value of r must be less than 1. If the absolute value of r is greater than 1, the series has no infinite sum. For instance, if r, the common ratio, is a 1/2, we know the absolute value of 1/2 is equal to 1/2, and that's less than 1, so you would be able to find the sum of that. What if the absolute value of r is -3? Well, the absolute value of -3 is 3, and 3 is not less than 1, so that would not have a sum. So make sure you look at r to proceed with the problem. So in examples 1 through 4, we are going to find the sum only if it exists for each infinite geometric series. So we have to identify the first term and we have to identify the common ratio. Well, the first term is easily identifiable in number 1 because 1 is your first term. And your common ratio, remember, is 1 over 27. Take the last term and divide it by 1 over 9. When you're dividing, remember, you're multiplying by the reciprocal of the second fraction. So that's 9 over 27, which is 1/3. And then look at 1/3. The absolute value of 1/3 is 1/3, which is smaller than 1. So you can find the sum. So now to use the formula, and we know it's an infinite geometric series, so you don't have to find the common ratio. But if you took 1 times 1/3, you would get 1/3. If you took 1/3 times 1/3, you would get 1/9. If you took 1/9 times 1/3, you would get 1 over 27. That's not something you need to take the time to do because it tells you it's a geometric series already. Okay, so now for the sum. Okay, so the sum is equal to the first term, which is 1, divided by 1 minus the common ratio. So that's the same thing as 1 over 1. I'm going to write as 3 over 3 minus 1 over 3. So it has the same common denominator. So at this point, you have 1 over 2/3, which is the same thing as 1 times 3 over 2, because you multiply by the reciprocal. Got to remember to flip that fraction. So your sum is 3 over 2. Okay, example number 2. We know the common ratio is in parentheses, so r is 1/2, and that checks because 1/2 is less than 1, the absolute value of 1/2. Okay, we need to find the first term. So the first term, replace I with 1. So 4 times 1/2 to the 1 minus 1, which is 4 times 1/2 to the 0 power, and any number raised to the 0 power is 1. So the first term is 4. And we have our 2 pieces of information that we need. Guess I could have started over here also. All right. So now for our formula, the sum is equal to the first term, which happens to be 4, divided by 1 minus 1/2. That is 4 divided by 2 over 2 minus 1 over 2, which is 4 over 1/2, which is the same thing as 4 times 2 over 1, which is 8. Sum is 8. Not too bad. At least the formula is not complicated. So it makes the problems pretty simple as long as you pay attention to R and actually see if you need to go on any further. Okay, the next one. So this is a series, and we know it's a series because there's a plus between each number. And if I asked you to write as a sequence, this is what you would write as a sequence. So, I mean, you can write it as a sequence just to figure out what R is. Not a big deal. So R, remember, it's going to be 16 divided by 8. So R is 2. Remember, the absolute value of 2, is it less than 1? We know it's not. The absolute value of 2 is 2, which is not less than 1. Therefore, you can't proceed with the formula. There is no sum. And our last one here. Our first term is 16. So this is our first term. Need to figure out what R is. So take 1/16 divided by -1/4. And that would be 1/16 times 4 over -1, which is 4 over -16, which is -1/4. And I always put my negative in the numerator just because I like to. And the absolute value of -1/4 is 1/4, which is less than 1. So that works just fine. So the sum is equal to the first term divided by 1 minus the common ratio. The common ratio is -1/4. So that's 4 over 1 plus 1/4. So that's 4 over 4 plus 1 over 4. So 4 is our numerator. Our denominator is 5/4. Keep the numerator the same, multiply by the reciprocal of the denominator, and you get, oops, I feel like I did something wrong here. Let's see. Oh, I'm sorry, the first term is 16. Well, I was looking at problem number 4. So that's 16, easy fix. So it's 16 times 4, 64/5. There we go. First page done. Pretty simple formula. We will use that same formula on the back page. So I will we don't really need to write it down. We know it's the sum is equal to the first term divided by 1 minus R. Okay, for this particular problem, a pendulum that is released to swing freely travels 10 inches on the first swing. So think about this. Think about in your mind a pendulum that has been released. It travels for 10 inches on the first swing. On each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance the pendulum swings? So the best way to do this problem is distance equals, so the first initial swing is 10 inches. It travels 10 inches. After that, each successive swing is 80% of that. So if you multiply 80% times 10, that'll give you 8 inches. But we want to write it as a geometric sequence. So we're going to have the 10 times 0.8, which is 80%. I'm not going to put, oh, you know what? I will. There we go. The next one will be 80% of that 10 times 0.8. So this is the first swing, or initial, I guess. Yeah, first swing. So first swing. This is the second and the third. So the third one would be 80% of the 10 times 0.80. So here's the second swing, and it'd be 80% of it. So that'd be the third. The next one would be what the third swing was, which is 10 times 0.80 times 0.80, and be 80% of that. But you get the pattern. You see what the pattern is. We don't have to write out every single one, but we're going to use that to find the sum, the total distance traveled. So in this case, instead of using the word sum, we're going to use D for distance. Same thing. So the distance is the first term divided by 1 minus the common ratio. And so the first term is 10. That's the first number in our sequence, right? Because 10, the next one would have been 8, because 10 times 0.80 is 8. And the next one would be like 6.4 and so on. But we don't need to write all that. We know that the common ratio is 8/10. So, or yes, 8/10. So 0.80 is 8/10. So the common ratio is 0.8, and you can write it as 0.8 or think about that. That's what I would do. So R is 0.8. So it'd be 1 minus 0.8. So that is 10 divided by 0.2, and use a calculator if you have to, if you can't do it. 10 divided by 0.2 happens to be 50. So the distance traveled by the pendulum is 50 inches. Pretty neat, actually, that you can use something like that, the sum of a geometric series in talking about a pendulum. Okay, and our last example, or actually we have two more. So in our next one, a rubber ball is dropped from a height of 60 feet. So each bounce takes it to 2/3 of its previous height. What is the total vertical distance the ball travels? So this one's a little tricky. And what I'm going to do is I'm going to sketch a picture. And you should too, because I mean, sketching a picture kind of helps you visualize it. And so, to the best of my ability, I'm going to try and make it as even as possible. And this is going to be representing the ground. There we go, the horizontal axis. Okay, so a rubber ball is dropped from a height of 60 feet. So we're going to say this was 20 feet, 40 feet, 60 feet. Okay, so here is a ball. It's dropped from a height of 60 feet. So, and you know when balls are, it's going to go like a parabola. There we go. So it drops, but it's going to bounce. So it's going to bounce back to 2/3 of the previous height. Well, 2/3 of 60 is 40. So it's going to end up right here. But then it has to come back down. Okay. And 2/3 of 40, that height is whatever 80 divided by 3 is. So 26 and something. So something like this. And at this point, you don't really care, but so you have a picture. So, oops, didn't do a very good job drawing that, but there we go. And then so on. And then it'll be 2/3 of whatever 27 is. So 18 or something like over here. We don't care. We're not going to draw the whole situation. I guess I should have put there we go. But notice what's happening here. You drop the ball, it goes to the ground, bounces, reaches its maximum and comes back down, bounces, reaches its maximum, comes back down, and so on. So there's a up down motion. So this one's different than the pendulum. So again, we're going to do a distance. So the distance is equal to the initial height that it was dropped from was 60. Here's the kicker. For the pendulum, we just did 0.10, or I'm sorry, 10 times 0.80 because it was 80% the previous. So we are going to, it is 2/3 of the previous height, but here's the thing. It comes back down. So it comes up and goes back down. So you have to compensate for that by putting a 2 here because there's an going up and going down. But then you have the 60 times the 2/3. Okay, so this is the first one dropped. So first, second, and the next one would be the third one. So the third one would be 2/3 that amount. So whatever 2 times 60. So take the second information. So this is from the second bounce, and it's going to be 2/3 of that. So I'm going to put a 2/3 here, or just 2/3 squared, right? And then the fourth one would be 2 times 60 times 2/3 times 2/3 times 2/3 again, and so on. So that is the pattern. So your common ratio is going to be 2/3. We know that. So here is what we are going to do. This one is a little tougher. So because there's this initial drop from 60. So this is how you do this particular one. So the distance is equal to 60 plus, then you're finding the sum of everything else. So the sum of the first term is going to be 120 times 2/3. And where did I get that? I got it from this right here. Because we're going to treat that as our like first one that actually goes up and down, instead of the one where it was drop, where it's just down. So that's why I'm counting this one right here as something totally different as this number right here, because it just goes down, but then the next one is up and down, and then up and down, and so on. So this is a sub 1 over 1 minus the common ratio. Now am I gonna give you something like that on a test? No. What about a pendulum? Probably, because that's not that hard. So let's do the fraction part. So we have 60, I'll go ahead and put the 60 here, plus 120 times 2/3 is 240 divided by 3, which is 80, over, I'm going to write 1 as 3/3 minus 2/3. So far now we have 60 plus 80 over 1/3. So we have 60 plus, this is 80 times 3 over 1. So we have 60 plus 240. So it's a grand total of 300 feet. All right. And our last one. I really like this one because it kind of makes you think a little. We have this decimal, it's 5 point something. So it's a pretty small number, 5 point whatever. But notice what's happening. There are digits repeating after the decimal, and the ones that are repeating are these three. The 0.146, 146, 146. If you look at the 0.146, those are 3 decimal places. 1 decimal place is the tenths place, 2 is the hundredths, 3 is the thousandths. So that's a key thing to remember here. So we don't care about the 5 right now. We only care about the stuff that's repeating. So let's write all the digits after the decimal place, and so on. We don't care. So what we do is we write the 146 and we are multiplying that by 0.001. Now, if you multiply 146 times 0.001, you get 0.146 because it's the thousandths place. And so the next one would be 146 times 0.001 to the second power. This is how you write a fraction in lowest terms that's repeating. The next one would be 146 times 0.001 to the third power, and so on. The one after that would be 146 times 0.001 to the fourth. That's how you write a fraction in lowest terms if it's repeating. If it's repeating with 2 digits, you would multiply in parentheses, you would have 0.01. If it was 1 digit, it would be 0.1. So that's how you do that one. And then we're going to use our formula for the sum of a finite geometric series. So it would be a sub 1 over 1 minus r. We know a sub 1, the first term, this is our first term. That's our second, third, so on. Okay, so first term is 146 times 0.001 divided by 1 minus our common ratio, and our common ratio is 0.001. And when you multiply the numerator, use a calculator for all of this if you want to, is 0.146. When you subtract the 0.001 from 1, you get 0.999. Now, this is really, really easy. I tell students you don't need a calculator to do this. Move the decimal point over 3 to the right, do it here also, and you get 146 over 999. And now here's where we add the 5 in, because there is a 5 point whatever. So we add that in, and we're going to write a fraction with a common denominator. So this one is 146 over 999. And this one, you want to multiply 5 times 999, which is 49.95 over 999. You can't add the 5 in. Well, I mean, you could say that's 5 and 146 over 999 and then write it as a improper fraction. So some students like to do that. So that is 5,149 divided by 999. Now, if you were to take a calculator and put that in, you're going to get 5.146, 146, 146, so on. And those are your notes for today. Have a great day, Algebra 2 students.